Alright, getting started in the input and output level 2 badge, we want to talk about processing. The IPO model would be inputting information, processing that information, and outputting that in results of that process. And so far, we've really talked about input and output, but to get further along in input and output, you have to get that last step of that, what we might call the IPO cycle. And the first step in understanding processing is understanding the math that we can do in Python. So we're going to take a look and we're going to do that. So like I said, we're kind of breaking this down into thinking about it as, well, let me show you what happens if you can just simply do some math. And so you could say, hey, I want to know the result of this. So you can always do that. 12. In fact, you can even just type things right in here if you ever need to do something. If you could figure out, if you wanted to find the average of some numbers and put it in parentheses, so if you could figure out the equation to do something, you could just do it, and Python will tell you the answer. So it's kind of like a built-in calculator. So that's one thing, but we're going to talk about how to do it like kind of within the cycle of our code. And so we're going to start with some input, then I'm going to show you the math that we can do, and then we're going to get to the output. So let's just say we have a number, and we're going to make it an integer for simplicity's sake to begin with. We have another number. Once we have some numbers, we can do many, many things with it. So let's just say we're going to create some sort of answer. Oops. We're going to print some sort of answer here. So I'm just getting that set up. All right. So you have your input and you have your output. Now, what is the answer? So as an example, we could say the answer is num1 plus num2. So we can add two numbers together. These are integers, so we can add them together. So the first thing is, like, what are our basic math operands, as they would say in math class? And so you can obviously do the plus is for adding, the minus is for subtraction. Those are pretty obvious, but then what happens when you get to like multiplying? Well, it's, in case you've never seen it before, it's the star. And division, sometimes you use that symbol in division, like to kind of look like a fraction and stuff, which really is division. So that's consistent with other things that you've seen. So those are your four basic ones, right? So you could do that for this. You could put any of those in here, and when you run it, you could get an error because I suddenly put two parentheses in here for no particular reason. Okay, let's get rid of one of those. Okay, number one is like 15, number two is 3, and the answer is 5 because I divided them. I apologize if you're getting static. I sometimes move my body around and it creates static in the microphone. I'll try to sit still. Okay, so there's your basic ones. There's another math operand in Python that is really handy, and that is the star star, which is for exponents. So I could say I want num1 to the num2 power and go like that. So if I want to say what is 2 to the 8th power, the answer is 256. You could, of course, square something in it by doing this, but if you want to do to a different power, right? So this would kind of be like x to the y on your calculator, so you can do that. Oops, if I had two stars in there. The final basic operand I would like you to know, as far as I know, it's the only one, other one, and that is what looks like a percent sign, and we call it modulus. Now, what is modulus? This is confusing to many uh, computer beginners or coder beginners, but it turns out it's something that is very useful in code and it helps us solve a lot of problems. So, what is it? Modulus is division, but the answer is only the remainder. So what do I mean by that? Well, if I did 16 divided by 3, you would expect 5.33333 as the answer to the division. But what this does is it, first of all, it treats it as if it's an integer. So like what would 16 be divided by 3 be if you didn't do 0.333? If you're looking for whole numbers, it would be 15 remainder 1. What modulus does is it throws out the 5, I meant to say 5 remainder 1. It would throw out the 5 and would give us only the remainder as the answer. So it's just basically a way to say, hey, if you're dividing these two numbers, what is left over after you divide them is the way to think about that. Kind of lets us soak up the leftovers, right? So 16 with a 3, there's 1 remainder, so the answer is 1. Let me show you. There's many things that you can do if you can find the remainder of a problem. Those of you who have done the number systems badge, you know that to divide, to get into binary, we can divide a number by 2 over and over again and take the remainders. And so this could help us build a binary calculator. So that's one of the uses of it. So it's like, why do I want to find the remainder? Well, maybe for binary conversions or some other kind of conversions. Maybe it's to find out if a number is odd or even. I'm going to show you that one in a second. Maybe it's to find out if something is a prime number. Because remember, like, if I run this again, and I say, hey, what is 15 divided by 3? If the answer is 0, that means it was an even division. There's no remainder, which means it has a divisor, which means 15 cannot be a prime number, right? So if I was to theoretically take some really big number and divide it by all the other numbers and it never came out to 0, that would tell me it's a prime number. There's better ways to do it, but that's one way to tell. Let me show you this odd even one. I'm not teaching if statements yet, but I just want to show you how this works. So I could say if my answer, when I divide by 2, so I'm going to make this a 2. In fact, I'm going to not even put num 2. I'm just going to say divide by 2. And if my answer is a 0, that means that it must be an even number, because any number divided by 2 is even, right? And if the answer is a 1, then I can print odd. So now we run this. Oh man. Sorry, I slipped back into old-fashioned Python 2. I've usually been good at avoiding that. All right, so I do, oh, well, what's this big number? Is that an even number or an odd number? Again, this number doesn't even matter, but let's put a 2. It's even, because the answer was 0. And if I ran that again, and I'm like, well, here's this really big number, and it ends in a 3, and I divide it by 2, it's odd, because, it got a 1 remainder. And so I can immediately tell if a number is even or odd. So you might think, well, what's the use of that? Like, obviously, we can do that as humans pretty easily. But maybe there's some time where you have to figure out that in some code in order to solve some other math problem. So that's something that can come in really handy. So the point of all this is that modulus is weird, but is really handy. Let me give you one other example. I'll put this back to num2. Our clock system, we have 24 hours in the day, but our clocks only show 12. So really a clock is running modulus 12. By that I mean you say, hey, we're in the 16th hour of the day, but because we are running a 12-hour clock system, what time is it? And so it divides 12 into 16, and it says how many times is that, does 12 go into 16 one time? How much is left over? 4, and so therefore it's 4 o'clock. So that's how you could figure out the time in this, and that's going to actually be an assignment later on in this batch. So there's a hint for you if you're watching this. So modulus is important. Modulus comes in handy. It's one that you really have to know in computer coding class. I'm just going to delete that. The other thing that's important is order of operations. So you should know PEMDAS. Please excuse my dear Aunt Sally, where you have parentheses, and then you have exponents, and then you have multiply or divide, and then you have adding or subtracting, as these are all important things. So imagine for a minute that we had some really complicated math problem here. Let's just say num1 to the num1 plus num2 power minus num2 divided by num1. No, sorry, num1 divided by num2. I was doing something in my head, and I wanted to use this one. All right, so let's pretend like the person, when we run this program, is going to say that this is a 5. So they're going to go 5 star star 5. Everywhere there's a, everywhere there's a num1, we'll do 5, and everywhere there's a num2, we'll say they entered a 2. I was going to kind of show you this underneath each one, but that's a lot of spaces. Okay, so let's just say they did something like that. So how would we solve this? Well, according to PEMDAS, we have to do parentheses first, right? So we end up with 5 star star 7, because we did the parentheses. And then we could say minus 5 divided by 2. And if you're good at math, you sometimes skip these steps. I was about to write 35 here, but that's not what we're doing, is it? We're doing 5 to the 7th power. Well, here's a funny thing. In the Spotlight search you can do on a Mac, I could do that and get the answer. So 5 star star 7 is 78,125. So it works on here. Remainders work on here too, by the way, the modulus. So I could say that, and remember that was a 4 a minute ago, and that actually works right here in the Mac. So that's kind of cool. Hopefully I'll finish this video before I run out of power. So it was 78,125, I believe, minus, what's 5 divided by 2? 2.5. And so the answer should be 78,122.5. So let's just see if I run that and if my order of operations is right. Now, imagine that you didn't know order of operations. Like, would it do num1 to the, so 5 to the 5th power, do whatever 5 to the 5th power is, and then just add 2 onto that? So that's a very different answer. So order of operations and thinking through order of operations is a big deal in this. So 5 and 2, 78,125.5, right? 78,122, yay, okay. So that's just an example of why order of operations is important. Now I'm going to get rid of that. And there's one more thing that we need to know, and that is that there's more to math, believe it or not, than these 6 things. And so you might ask yourself, well, where's all the other things that math can do? And so because we don't use them all that often, Python has put some math kind of hidden away in a special library that doesn't load, so it doesn't take up all the room it might need. But if I was to say import math, it would load all the different math things in, and we would call this a library of math functions that we can use once we know that. So as an example, we can say, hey, we want to use the square root of num1. So when I run this, now there's a function that wasn't there before. Now there's a function for square root. So when I say 25, it says the answer is 5 because I found the square root of 25. So, that's when you could imagine, like, oh, why don't they just have one of these for that? But we can't really make the square root with our keyboard, so we can just bring it in like that. Now, here's one I find very funny, is that you can actually do the power. So, this and this, are like exactly the same thing, right? So, go figure. I don't know really why they made a power one when we can just do it this way, but they did. Other math functions include anything from being able to round like a number, like, hey, do the division and then round it off, or find the average and round it or something, to trigonometry kinds of things like sines and cosines exist. So if you can think of some sort of kind of multi-step math thing, there probably exists a function for you to find the answer much easier than trying to figure it all out on your own. What I think is kind of cool is that it's like pi is included. So if I was to just say over here to print math.pi, it'll print, right? I just added this to the end of my program. So the first thing it's going to do is it's going to ask me for some numbers. There, I did it again. I forgot that I need parentheses. Goodness gracious. So, this part I don't really care about right now. Oh, well, it's trying to do okay, yeah. It doesn't like to try to do things to raise to the 123rd power, so I guess I should do 2 to the 8th power. There we go. And then I told it to print pi, and then look how it has this, thing memorized. So it can have a really precise pi. So if you needed to find pi r squared or 2 pi r or whatever it is, you'd be able to easily do it based on just bringing in math.pi, and you can just use that as kind of a constant that doesn't change in any of your code. So math functions, order of operations, and then the 6 different operands are all things that you can do in math, and that will help you make some interesting processes that you can then output the answers to. So that's what this badge is all about, and good luck on solving some of the problems that are all now math based in the rest of this assignment.